Welcome to solverfy.
We're asked to adapt Prim's and Kruskal's algorithms to construct minimum spanning forests instead of minimum spanning trees for weighted graphs. So we're told that a minimum spanning forest in a weighted graph is predictably a spanning forest that has minimal weight. So to do this, first let's consider Prim's algorithm. So how are we going to make adjustments to this? Well, if the weighted graph is not connected, suppose that the weighted graph G contains K connected components, and we have that when no more edges can be added to the already constructed tree, and if the graph contains less than K connected components, select one of the vertices that is not present in the previously constructed trees, repeat Prim's algorithm with this vertex as the root. And we have a minimum spanning forest when the found forest contains K connected components. So, in other words, more explicitly, the algorithm follows these steps. Let the given graph contain K-connected components. In the next step, create a graph that contains only the vertices of the given graph and no edges. So far, this is pretty similar to the previous version of Prim's algorithm. Next step, select a root. Again, just like the previous algorithm. And then add the edge from the root to another vertex with the smallest weight. So again, this is pretty similar to Prim's algorithm so far. Next step, you want to repeatedly add the edge from a vertex in the already constructed tree to another vertex. From a vertex in the already constructed tree. To another vertex. Obviously, this vertex is going to be outside the tree with the smallest weight. In the next step, suppose that no more edges can be added to the already constructed tree. Suppose also that the graph contains less than k connected components. Then we'll select one of the vertices that is not present in the previously constructed tree. And repeat previous steps with the new vertex as root. And finally, once the graph contains k-connected components, there's a minimum spanning tree. A minimum spanning forest. So these are the new steps, which I've drawn with a bar on the left in red for Prim's algorithm. We'll want to make similar adaptations to Kruskal's algorithm. So, suppose that the given graph has k-connected components, then we'll find a minimum spanning forest when the forest contains k-connected components. So, likewise for Kruskal's algorithm, we'll begin in a similar way. So let the given graph contain k-connected components. In the next step, we'll want to create a graph that contains only the vertices of the given graph and no edges. And in the next step, we're asked to repeatedly select the edge in the given graph with the smallest weight and add it to the graph T. Add it to the graph T as long as it doesn't cause a circuit. This is the edge in the given graph with the smallest weight. So far, this is all pretty much the same as Kruskal's algorithm. In the next step, we have that once the graph contains k-connected components, we have a minimum spanning forest. And I will draw a red line to the left of these steps to emphasize that these